Okay, this section of the course is going to be on natural number exponents. And if you remember, a few videos ago we did talk quite a bit about exponents, but in this lesson we're going to go in a little bit more detail and get into a little bit more of the algebra and solving and actually really simplifying exponents. So let's just do a little bit of review first. And for that we're going to start off with something pretty easy. What if we have something like 5 raised to the third power? What does that mean? Well, what it means is 5 times 5 times 5. So just as a review, 5 raised to the third power, or 5 cubed, is simply the bottom number multiplied by itself however many number of times as the top number. So in this case 5 to the third is 5 times 5 times 5, and we do it 3 times because we have a 3 here in the top. Okay? Let's take a look at something like negative 4x to the fifth. How would we write this without using any exponents? How would we expand this out? Well, first, just take note here. There's no parentheses anywhere, and so we have something raised to the fifth power, and that thing that's raised to the fifth power is the x here. The negative 4 is completely unrelated because there's no parentheses. So this is going to equal negative 4, okay, times x times x times x times x times x. And we multiply by 5 x's, x times x times x times x times x, because we're doing it 5 times. And the negative 4 is just multiplied by this whole thing. Okay? So that's what that would look like. Now contrast that, what we just did right here, with something that looks like negative 2y to the fourth. What would that look like? Well, you see the difference between this and this is, in this case, we were only raising the x to the fifth power, and we had the negative 4 out multiplied in front. In this case, the entire contents of the parentheses, that's why we have the parentheses here, the entire contents in the middle here is raised to the fourth power. So in this case, we'd have negative 2y times negative 2y times negative 2y times negative 2y. And we're taking negative 2y and we're multiplying that 4 times. Okay? And so when you do this multiplication out, you'll see, you'll get the answer. But basically we're taking the center, whatever's in the parentheses here, and we're applying the exponent, multiplying it by itself 4 times, because we've got the whole thing written outside of the exponent there. Okay, so that's just a little bit of review. Remember, the exponent pretty much just tells you how many times to multiply the inside part by itself. It's not too terribly difficult. So let's go ahead and take some different kinds of examples. Now we're going to get into the meat of this section. What if you have something that looks like x to the fourth times x to the third? Now you may remember this a little bit from the earlier section of the course when we did some algebraic simplification, but in this part of the course we're going to just pound it in, really hard and make it really ingrained. When you have two exponents, two powers of x or whatever multiplied by each other, like we have here, and the bottom number, the base is really what it's called here, in this case it's x, is the same thing. When you have the same base, okay, you can write this in this case as, and we'll explain it in a minute, x to the 7th power. Okay, so when you have two exponents multiplied by each other and the base is exactly the same, in this case it's x, then to simplify it, all you do is you add the exponents together. We're going to do this over and over and over and over and over again. It's going to be really boring after a while, but that's pretty much how you simplify exponents when you have them multiplied together. Let's take another example. What if I have x to the 5 multiplied by x to the 5? In this case, the base, which is x, is the same, and so I can just add these exponents together, which gives me x to the 10th power. Okay? And if you really want to understand why this is the case, we can just go and move over here and I'll explain it. What is x to the fifth if you were to write it out? X times x times x times x times x. Okay, that is x to the fifth. What is x to the fifth? The second x to the fifth. Again, it's x times x times x times x times x. And these two things are multiplied by each other. The top x's multiplied by the bottom x's. So if you were to simplify this as an exponent, it would be x to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, x to the 10th power. So you see, when the base is the same, once you write it all out, that's why you add the exponents together, because when you write it all out, that's the same number of things. In this case, it would be x to the fourth, 1, 2, 3, 4, times x to the third, 1, 2, 3, so that's why you just add them up. But the shorthand way to remember it is just if the base is the same, add the exponents. Okay? Now what if we have something a little bit more interesting? What if we have y to the third times y squared y to the fourth? Okay? We could do this a number of ways, but I'm going to show you one. First, we're going to work inside the parentheses first, because that's what we're taught to do in algebra, basically. So I'm going to carry the y to the third over. I haven't touched it. I'm just rewriting it. And I'm going to simplify the middle part. Y squared times y to the fourth. The bases are the same, so I can add this. That's going to be y to the sixth, because 2 plus 4 is 6. Now, continuing to simplify this, again, the bases are the same, so I can add the exponents. Y to the ninth. So the answer is y to the ninth. Okay? This isn't really that terribly hard. You just add the exponents. Now what if you have something like 4x squared parentheses 3x to the fifth? Okay? You can start to skip steps as you become more comfortable. I'm not going to skip any steps now. Let's just go ahead and do it. Take it one step at a time. 3 times 4, positive 3 times positive 4 is 12. And I have an x squared here. I'm just going to write it down. And I have an x to the fifth here, and I'm going to write that down. All we've done is multiply this times this. 3 times 4 is 12, and we didn't touch the x squared, and we didn't touch the x to the fifth. Okay? Let me carry my 12 over. The base is the same here, and 2 plus 5 is 7, so I have x to the 7. And that's the answer, 12x to the 7. So the only real multiplication that I actually had to do was on the outside here. So you just take it one step at a time, and you know, do your best to break it down and make sure that you're doing something legal. And in most cases, you're going to be golden. Be perfectly fine. And exponents are actually extremely important, you know, in all areas of math, especially algebra, calculus. Very, very important. So I'm going to harp on this quite a bit. What if you have something like negative y squared times 4y to the third? And I want to multiply those two things together. Well, again, let's work with the numbers first. I've got a negative 1 here sitting out in front of this y squared, so negative 1 times 4 is negative 4, okay? And then I've got a y squared sitting here, and a y multiplied by a y to the third sitting here. So I'm going to have a negative 4, and then it's the same base here. The y is the same base, and 2 plus 3 is 5, so it's going to be y to the 5. Negative 4 y to the fifth. It's going to be that guy. And I'll just do one more of this type here. What if I have 6x to the third multiplied by negative x squared multiplied by negative x to the fourth? How am I going to deal with that? Again, let's start with the numbers. I've got a 6 here. I've got a negative 1 in here because that negative 1 is implied in front of the x squared, and I've got a negative 1 over there for the same reason. Well, I can tell you right now that this negative 1 times this negative 1 is going to give me positive 1, because negative times negative is positive, and 1 times 1 is 1. So negative 1 times negative 1 is going to give me positive 1. And positive 1 times the 6 is just simply going to be 6. So I'm going to carry over my x to the third, my x squared, and my x to the fourth. The only thing that happened here is these negatives went away because negative 1 times negative 1 is positive 1, so I just rewrote it all again. Okay, and then in this case the 6 will come down, and all these exponents have the same base, so I can just add all of them up. 3 plus 2 is 5, 5 plus 4 is 9, so the answer is 6x to the ninth. And that's it. So that's pretty much what you do with exponents when the base is the same, and you could just add the exponents up like that. Now, I just want to give you this. We're not going to go through a bunch of examples, but I want to give you one taste for when you couldn't add them together. What if you had 12x squared y to the ninth? This is an example of when you can't really do anything. Don't be tempted to add 2 plus 9, okay? Because you can't. The bases have to be the same. I've got an x squared here, and I've got a y to the ninth here, and I've got a 12 sitting out front. There's absolutely no way I can simplify this any more than it already is. I can't add these. I can't multiply these. I mean, they're already multiplied together, but there's nothing I can do because these are totally different variables. Now, if this, instead of being a y to the ninth, if this were an x to the ninth, well, yeah, then I can simplify it by adding the exponents. But the way I wrote it originally, it's really untouchable. You really can't do anything. Okay, so that's how you handle it when you've got two bases that are the same and you can just add the exponents up. Now we're going to look at something a little bit different. What if you have something like 3 squared with the parentheses raised to the fourth power? Okay, this is how you do this. What you really end up doing is you take the outside exponent and multiply it by the inside exponent. So the answer here is going to be 3, and then 4 times 2 is 8 to the 8th power. That's going to be the answer. And to convince yourself of that, I'm going to blow through it real fast. I don't like to do too many proofs, but I think this is kind of neat. Well, let's go ahead and write this out. What does this mean? I've got 3 squared times 3 squared times 3 squared times 3 squared. I did it 4 times because the entire inside here is raised to the fourth power. Now let's go ahead and expand everything here. What is 3 squared? Well, that's 3 times 3. Okay. 3 times 3 for the second one, 3 times 3 for the third one, and 3 times 3 for the fourth one. So I've got a bunch of 3's here. Now all these 3's are multiplied together, so I can write this as an exponent. 1, 2, 3, 4, 5, 6, 7, 8. 8. And that equals what I told you the quote shortcut is basically all you got to do is when you have something raised to a power and another power outside, you just multiply both powers together, and that gives you the answer. And the reason is because everything inside is being expanded, and so that's why you can multiply and do it. Just one example to show you why that's true. We're not going to be doing that for the remainder of our class. We're going to be simply using the shortcuts. If you were to, and you can see why exponents are useful. I mean, if you had to write all that stuff out every single time to write an exponent or an equation or something like that, your hand would go numb. So let's just apply that. Let's say I have y to the fifth raised to the 3 power. Well, all I got to do is write y down, and I've got a power raised to a power, so 5 times 3 is 15, and that is the answer. What if I have a to the third raised to the 7th power? All I got to do is write a down. 7 times 3 is 21. Okay?